we are given f of x is equal to arc sine of 1/2 x, now we will find the derivative of this function, since we are going to find the derivative of the following function. Now, let us first define substitution for implicity. Let u be 1/2 x. So f of x is equals to arc sine u. Next, we are going to find du dx. Now, du dx is 1/2. Why? Because we derive 1/2 x. So, the derivation of 1/2 x is 1/2. But let us all remember the derivation formula of trigonometric function. Since we have arc sine, the derivation of arc sine u is d over dx arc sine u. The derivation of that is 1 over square root of 1 minus u squared multiplied to du dx. That is the derivation of trigonometric function in arc sine. Now, let us all substitute each from step 2. Since the given is f of x is equals to arc sine of 1/2 x. In deriving the function, we must follow the formula of trigonometric function, or in deriving trigonometric function. Now we have here now f substitution of x minus our u is 1/2 x. Multiplied to du dx. Our du dx is 1/2. Now, we're going to use these formulas to get the derivation of the given function. So, from the given function, f of x equals to arc sine of 1/2 x. We have now the derivation of that. We're going to use this formula. So 1 over, I forgot, multiplied to du dx. So 1 over square root of 1 minus u squared. Our u here is 1/2 x. So 1/2 x squared multiplied to du dx. Our du dx is 1/2. Now, we can simplify 1/2 x squared. So 1/2 x squared become x squared over 4. X squared over 4. Now we have f of x is equals to 1 over square root of 1 minus x squared over 4 multiplied to 1/2. Before multiplying 1 over square root of 1 minus x squared over 4 to 1/2, we should simplify first the denominator. So from this, square root of 1 become square root of 4 minus x squared over 4. But 4 can be squared, so square root of 4 is 2. So the denominator is square root of 4 minus x squared over 2. This is now our denominator. Now, let's simplify. Dividing square root of 4 minus x squared divided by 2 is also the same as multiplying by 2. So, we have now f of x is equals to 2 over square root of 4 minus x squared. So this is now the derivation of f of x is equals to arcsine of 1/2 x, which is the first derivation, f of x of 2 over square root of 4 minus x squared. Now, we're going to find the first and second derivative of the given function. Now, we have here the given function. R of x is equals to cosine of x minus pi. Now, we will use the chain rule for differentiation. So, d over dx cosine u is equals to negative sine u du dx. So, let us put that u is x minus pi, and the derivation of u, or the du dx, is 1. Now, let us use, or let us apply the chain rule from Rx equals to cosine of x minus pi. So, the derivative of R of x is, derivative of cosine is negative sine. And since u is x minus pi multiplied by du dx, which is 1. Now, negative sine of x minus pi multiplied to 1 is negative sine of x minus pi. Now, this is our first derivative from R of x equals to cosine of x minus pi. Now, let us find the second derivative from the first derivation. We will use again the chain rule. Let u be, again, u is x minus pi and du dx is 1. And then apply the chain rule. Since we have the derivative of, or the first derivation from the function, which is this, our first derivative, we're going to use this in finding the second derivative. So, the second derivative is the derivation of negative sine is negative cosine, and then x minus pi multiplied to 1. Negative cosine of x minus pi multiplied to 1 is negative cosine of x minus pi. Now, this is our second derivative. Again, we only use chain rule, and by identifying u and the derivative of u, or the du dx, and apply this formula, and we come up, or we found the first derivative and the second derivative from the given function. Now we have a worded problem here. For example, an airplane is flying at an altitude of 2 miles and will pass directly above the ground radar station. The radar detects that the distance of the plane from the station is decreasing at the rate of 200 miles per hour when the plane is 15 miles away. What is the speed of the plane? Now, we have here the given. Let's say that S is 15 miles, which is the distance from the plane to the radar station, equals to 2 miles, so the altitude of the plane, and ds dt is the 200 miles, or the decreasing rate per hour, not miles, but decreasing rate per hour. And we put negative sign because it is the decreasing rate per hour. Now, we have to find the x and dx dt. Now, in solving for dx dt, we have here the Pythagorean theorem. S squared is equals to x squared plus y squared. All we have to do is derive this equation. So, since we're going to find the dx dt, so the derivative of s squared is simply 2s ds dt, and x squared is simply 2x dx dt, plus y squared is 2y dy dt. And after that, divide both sides by 2. So cancel s ds dt equals x dx dt plus y dy over dt. And since we are solving for dx dt, we should cancel x. So, after dividing both sides by 2, we have now s ds over dt is equals to x dx over dt and y dy dt. And remember that the given y is 2 and the derivative of 2 or derivative of constant is 0, and 2 is a constant, so this is 0. So this is not exist anymore. It does not exist anymore because it is 0 according to the given. And since we are solving for dx dt, we have to divide both sides x so that we can cancel x. So divide both sides by x. So cancel x, and that's it. So to make it clear, divide both sides by x. So cancel by x. So we have left s ds dt over x. This is now our dx dt. And after solving for dx dt, we're going to solve now for x. Now in solving for x, we have again Pythagorean theorem. S squared is equals to x squared plus y squared, and substitute all the numbers that are found in the given. So we have s is 15, so 15 miles, so 15 squared is equals to x squared plus y squared. And remember that in the given y is 2 miles, so 2 squared. So 15 squared is 225 and x squared, and 2 squared is 4. Now we need to subtract 4 both sides. Now we have 225 minus 4 equals x squared. So 225 minus 4 is 221. And since we are solving for x, not x squared, we have to put square symbol so that we can cancel this. And square root of 221 is 14.87. You can check it in your calculator that the square root of 221 is 14.87. Since we have already identified x and dx over dt from step 1, if you can still remember from the previous that we just solved, dx dt is equals to s ds dt over x, and x is 14.87. Now all we need to do is substitute all the numbers from the given and from the x and dx dt. So just copy dx over dt. So s is again 15 multiplied by ds dt. Our ds dt is the decreasing rate per hour, or the negative 200 over x, and our x is 14.87. Now in order to solve for the speed of the plane, 15 divided by negative 200 is negative 3,000. Negative 3,000 divided by 14.87, we have now dx dt of 201.7 miles per hour. This is now the speed of the plane that is questioned in the worded problem. Now we have another worded problem. We have here the question: find the points of inflection of the graph of the function given, which is f of x is equals to x cubed plus 9x. Now, if there are any, determine where the graph is concave upward and where it is concave downward, and draw a sketch of the graphs and show a segment of each inflectional tangent. Step 1. We need to find the first derivative from the given function. Since we have f of x is equals to x cubed plus 9x, the first derivative of the given function is simply 3x squared plus 9. And the second derivative from the first derivative is 6x, because 9 is constant and we all know the derivative of constant is 0. Now in finding the inflection points, we must equate the second derivative to 0. Since our second derivative is 6x, we need to equate it to 0. So in order to find x, divide by 6, both sides cancel, and x is equals to 0. So the inflection points are 0, 0. So this is now our inflection points. Now since our inflection points is 0, since x is 0, and this is our inflection points. Now the interval gives us from negative infinity to 0 and 0 to positive infinity. So negative infinity to 0 is our concave downward. And 0 to positive infinity is our concave upward. Now, in sketching the graph and showing the inflectional points of tangents, this is how you sketch it. So, again, the inflection points, since x is 0, the inflection point is 0. Now in the Cartesian plane, this is our Cartesian plane. Our inflection point is 0, 0. So this is our inflection point. Can be found here. And since the coefficient of x cubed is positive 1, this only means that the graph will rise to the right, and fall to the left. The inflection point at 0, 0 is where concavity changes to the left of x is equals to 0. Now the graph is concave downward, and to the right of x is equals to 0, the concave is concave upward. And this change in curvature, and it is what defines the inflection points. And there is no extrema can be found in the graph, since 3x squared plus 9 is always a positive. So there are no local minima or maxima. So this is our graph for the worded or the given worded problem. Now, moving to the integrals. So we have a definite integral here, and we need to evaluate the following definite integral. So we have here the integration from negative 1 to 2 of 8 minus t squared dt. So before we're going to identify the answer of the definite integral, we have formula or a lot of formula that we can use in order to get the answer. So we have formula 1 that we can use. We have, this is integral symbol, dx. So x. So example is, we have, for example, this is formula 1 that we can use. So for example, we have integral symbol for dx. So for dx, the answer is 4x. Okay, so that's the basic one for that we can use for, this is formula 1. And we also have formula 2, again the integral symbol, and then a stands for constant, f of x dx. So if we encounter this type of equation in integrals, in solving in both definite or indefinite integrals, a stands for constant, so a outside, put outside the integral symbol, and then f of x dx. That's it. That is the formula 2 that we can use in both definite and indefinite integral. And we also have formula 3. So we can also encounter this type of problem. So integral symbol, f1 of x plus f2 of x. Dx plus f of 2x dx. This is integral sign, yeah. So for example, if we encounter this type of problem again, we can rewrite it. We can rewrite it like this. So integral symbol, f1 of x dx plus integral symbol again, and then f of 2x dx. If we're going to encounter this type of problem in definite and in both indefinite and definite integrals. And we also have some exponents. For example, in formula 4, so integral symbol x and dx. Like for example, if we encounter a type of problem, so we can write, the formula here is that we add, if we encounter a constant having a exponent, we should add 1. So xn plus 1 over the sum of the number plus 1, so n plus 1. And then, yeah, that's it, dx, wherein n is not equal to -1. So those are the formulas that could help us in order to solve for both definite and indefinite integral. Now going back to the given problem, integration from -1 to 2 of 8 minus t squared. So by using the formula that I just showed, you can just look backward, then find the formula that we can use in order to find the definite integral of the given problem. So we can use formula 1. Yeah, because 8 is constant, so we will put 8 outside the integral symbol. So as simply as 8, since 8 is constant again, integral symbol, then t squared dt. Now going back to the given problem, the integration from -1 to 2 of 8 minus t squared dt. So again, 8 is constant, so 8 puts outside in the integral symbol. So 8, we can use formula 1, integral symbol dt minus, again apply the formula 3, integral symbol dt, integral symbol t squared dt. Now again, since we have t squared, we can use formula 4. So all the formula in the previous slide that I just explained, we can really use those formulas in finding the definite or indefinite integral. So since we have t squared, so exponent is 2, so 2 plus 1 is 3, so t squared become t cubed, and over n plus 1, so our n is 2, so 2 plus 1 is 3 dt. Now 8 dt becomes 8 t minus t3 over 3. After this one, we're going to substitute -1 and 2 to all of the t here, and we're going to use f of b, a function of b minus function of a. follow this f of b minus f of a. So, first, in integral, since this is the symbol of integral symbol, b is our upper limit and a is the lower limit. So 8t, so our upper limit is 2. 2 cube over 3. After that, minus f of a. So a is our lower limit and our lower limit is negative 1. So just simply substitute all. Minus t cubes, or t is negative 1 over 3. That's it. And just simplify all. We have 16 minus 8 thirds minus negative 8 and minus 1/3. 16. So 16 minus 8 thirds minus negative 8 minus 1/3. So 16 minus 8 thirds is 40 third minus negative 8 minus 1/3 is 25 third. So 40 thirds minus 25 thirds is 63 third. And 63 divided by 3 is 21. 63 divided by 3 is 21. So 21 is the answer for integrating the definite integral of integration from negative 1 to 2 of 8 minus t squared dt. So the answer is 21 by using the formulas that I just explained. And remember that in integral, again, if this is the integral symbol, this is the integral symbol, this is the upper limit and this is the lower limit, and we can use at last f of b minus f of a, and that's it.